Let's see what happens in the healthcare sector if it comes to models and agents. So we'll stay on the training side for now. There's two examples for two models that are extremely well used already. This is the BERT one with a lot of data needed, as you can see, a lot of GPUs needed. And this is just the initial training. As we know, training has to be continuously repeated and improved. So this is just the beginning. And it has been used in so many different use cases, as you can see, for clinical support, patient outcome prediction, drug treatment discovery, extremely important areas. Another model is the SAM image segmentation model. You see, tremendous amount of data. This is what we cannot even anticipate easily, right? Those millions and billions of images of data, tons of data. Just for this initial training, 256 GPUs has been used for all the use cases after, like personalized treatments, quickly identified diseases, precision on diagnostics, etc. So, having these two in mind, now the question is, what the DE-CIX can deliver to optimize this, to support this further, now getting into the infrastructure. And we have to ask ourselves where the data comes from. Data is everywhere, literally. But what we do not have everywhere is the compute. So, data everywhere, computing power somewhere. So, digital infrastructure has to make sure that the data can be brought where the compute is in the most efficient and secure way. We're talking about healthcare. There is not a second segment probably where sensitivity on data is so important, and security, of course. Then, what we thought is, let's help here with a multi-cloud routing technology, because a lot of data comes from the different clouds. We all know them. Those are our friends from the cloud application sector, cloud service provider sector. And a lot of logos there engaged. Those are just the main, the well-known hyperscalers, but there are also others, more specialized as well. This is just one example. So what the cloud routing can deliver here, there is one access to the different cloud routing environments in different markets, as close as possible to where the data is, route this properly, with a lot of bandwidth, of course, and using the help of ISP, subsea providers, and carriers to bring this data from the ecosystem where the routing happens to the compute and back. So the routing enables a one aggregated, very secure, and less complexible and very highly performable at the same time way to bring all these data sources together and transport this to compute and back. So that's the cloud routing element of the DE-CIX. Let's move further now. What do we have else if it comes to compute and training? Of course, we do have the talk about the hyperscale data centers. This is also a very interesting picture here. Those are hyperscale data centers and numbers per region. US, of course, no surprise, a lot still. Still a lot to be done, but there is a kind of a proper level. Europe is growing as well, but look at LATAM, 10 only. Africa, 1 is 1 for entire Africa. So then asking myself, what are the strengths here? Strengths is, of course, obvious. Like Start Campus example with the big investments on GPUs. We know there will be the installation of Microsoft there live in Q1 next year. This is what can scale easily. But we have also limitations. Limitations in terms of number, of presence of those hyperscale data centers, also because power limitations are still there. We have limited units and certain barriers of access still. We're not there where it should be. Therefore, we thought, let's look into the universe of data center operators we also have. They are not called hyperscale data center operators. They are a lot. And listen and see, the picture now changes. We have a lot of other data center providers in those Pan-Atlantic economic region that are not called hyperscale giant data center facilities. So I think it's obvious. We thought how to bring different GPU as a service installations into one virtual community that will allow different installations in different data centers to be used in one environment we call GPU as a service community. So this will allow organizations, they need more compute power, more GPU power to bring different installations from different data centers, as you can see here, 1, 2, 3, 4, within a metro, because we need a good latency here as well, using, and this has been presented by Nokia, the Ultra Ethernet technology as DE-CIX introducing the GPU as a service community offering. Utilizing GPU setups in smaller data centers as well, in edge data centers as well. I think this is needed, as we need also the giant data centers. So it's not either or, it's and. And this optimizes the usage of existing infrastructure. There are a lot of advantages. I explained already, there are existing data centers with existing installations. A lot of GPU service providers are already on the market. We have an example where we are about to build a community with the GPU as a service setup in Brooklyn, with the one in Manhattan into one GPU training environment for a customer from the fintech sector. Limitations is obviously they are not that big, cannot be that big because it has to stay within the metro, and we have costs of the equipment upgrade constantly. But very helpful. Now, multi-cloud routing for the data access, just to summarize a bit. Then you have the GPU as a service community offering, to allow different GPU as a setups to be brought together, and we'll get into the models. That's the goal here.